Hello everybody, welcome into another lesson. So today we are going to talk about two variable equations. And this actually won't be that bad of a lesson, because for the first part of this, all they're asking us to do is state whether each ordered pair, such as what we have here, 3, 4, and 7, negative 6, is a solution to the equation. You have your equation of two variables, 5x plus 2y equals 23. Some of you may recall from pre-algebra how we had equations of two variables. When you have x and y together, you graph it, you get a line. And then you have ordered pairs. The first coordinate in each ordered pair is your x coordinate, the second coordinate is your y coordinate, okay? If that ordered pair is a solution to the equation, it lies on that line. If an ordered pair is not a solution to the equation, then it does not lie on that line. So we're going to determine whether each of these ordered pairs lie on this line. So what you got to do, you have your first coordinate 3, 4. Your x coordinate's 3, your y coordinate's 4. You're going to take your 3, your x coordinate, put that in for x. So we're going to start with 3, 4, right? So take your x coordinate of 3, put that value in for x. So you have 5 times 3 plus 2 times your y coordinate of 4. Set that equal to the right side of 23. Well, 5 times 3, that's 15, plus 2 times 4, that's 8, equal to 23. And then you have 15 plus 8 equals 23. So 23 does in fact equal 23. So therefore, 3, 4, the answer is yes. That does lie on this line, and it is a solution to the equation, okay? So basically, when you put in your x and y values, the left side should equal the right-hand side. Now let's do the same here with 7, negative 6. So you're going to take your 7, put that in for x, so you'll have 5 times 7 plus 2 times negative 6. Set that equal to 23, okay? Well, 5 times 7, that's 35. Plus 2 times negative 6, that'd actually be minus 12. So you have 35 minus 12. Set that equal to 23. Well, 35 minus 12, that happens to be 23. 23 equals 23, so 7, negative 6, the answer to that is also yes. So both of these ordered pairs are solutions to this equation, and therefore that means they both lie on this line. And I do got more examples here. This is going to seem simple today, but believe me, it's going to tie into some future lessons that we're going to be doing here. Alright, let's see. We have 4m minus 5n equals 9. 4m minus 5n equals 9. The ordered pairs they give us are 6, 7, and what's the other ordered pair? 6, 3. Alright, so we have to determine whether 6, 7 and 6, 3 are solutions to this equation. Well, your ordered pairs always go in alphabetical order. I know we're not working with x and y, but this goes in alphabetical order in your ordered pair. So your first coordinate would be m, your second would be n. So for the ordered pair 6, 7, we're going to work that out first. You'll take your 6, put that in for m, so you'll have 4 times 6 minus 5 times your 7 for your n coordinate, we'll set that equal to 9. Alright, so 4 times 6 is what? Well, that's 24. Minus 5 times 7, well, that's 35. Set that equal to 9. Well, what's 24 minus 35? That's negative 11. We know that definitely does not equal 9. So therefore, the answer is a big fat no. 6, 7 is not a solution to this. It does not lie on that line. Well, how about 6, 3? What if we tried that? Okay, so you'll still take your 6, put that in for m, so you'll have 4 times 6 minus 5 times your n coordinate of 3, so minus 5 times 3, you would set that equal to 9, okay? So 4 times 6, that is 24, minus 5 times 3, that's 15, which would equal 9. Well, 24 minus 15 does in fact equal 9, and 9 does equal 9. So yes, 6, 3 is a solution. 6, 3 is in fact a solution to 4m minus 5n equals 9, which means 6, 3 does lie on this line. Alright, we have 3a minus 2b equals 13. They want to know, do the points 3, negative 2, are the points 3, negative 2 and 5, negative 1, are those solutions to this equation? In other words, do they lie on this line? Well, let's figure out 3, negative 2 first. So let's write it here on the left-hand side, 3, negative 2. Now you'll put your 3 in for a, so you'll take 3 times 3 minus 2 times that negative 2 for b, set that equal to 13. Well, 3 times 3, that's 9. Now negative 2 times negative 2 turns into positive 4, so you have 9 plus 4, set that equal to 13. 9 plus 4 does in fact equal 13. So we have a true statement, 13 equals 13, so yes, 3, negative 2 is a solution to this equation and therefore lies on the line. The other question is, does 5, negative 1, does that work as a solution? Or in other words, does it lie on this line? So take 3 times your a coordinate of 5 minus 2 times your b coordinate of negative 1, set that equal to 13. Well, 3 times 5, that's 15. Then you have negative 2 times negative 1, that turns into plus 2. So you have 15 plus 2 equal to 13. Well, 15 plus 2, that's 17. 17 clearly does not equal 13. So 5, negative 1, the answer is no. That is not a solution. In other words, it does not lie on that line. Okay. Let's see. How about 2x plus 3y equals 13? They want to know, or we want to know, is the ordered pair 5, 1 and the ordered pair 11, negative 3, would those be considered solutions to 2x plus 3y equal to 13? Would that work? Well, let's start with 5, 1. Let's address 5, 1. So you'll take your 2 times your x coordinate of 5 plus 3 times your y coordinate of 1, set that equal to 13. Well, 2 times 5, that's 10. Plus 3 times 1 is 3, so you'll have 10 plus 3 equals 13. Well, 10 plus 3 is in fact 13, and yes, 13 equals 13, so the answer is yes. 5,1 is a solution to 2x plus 3y equals 13. In other words, 5,1 lies on this line. Now the other question is, does 11 negative 3 work as a solution, or is it on the line? Again, take your 2 times your x coordinate of 11 plus 3 times your y coordinate of negative 3, set that equal to 13. Well, 2 times 11, that's 22, plus 3 times negative 3, that actually turned into minus 9. Would that be equal to 13? 22 minus 9, well, that is in fact 13. So yes, 13 equals 13. So also a yes on 11 negative 3. That is also a solution to this equation, therefore meaning 11 negative 3 lies on this line. And I know today seems kind of trivial, like, oh, Matt, this is easy. Why are we doing this? Well, it's going to come into play in future lessons. I think we'll do one more of this type. So how about 5x minus 4y equals 9? So we have 5x minus 4y equals 9. They want to know, is 7/6 a solution as well as negative 3, negative 6? Would those ordered pairs be viable solutions to this equation? Or in other words, would they rest on that line? Will those points rest on that line? Let's find out. So we'll start with 7/6 here. So you'll take 5 times your x coordinate of 7 minus 4 times your y coordinate of 6, set that equal to 9. 5 times 7, that's 35. Minus 4 times 6, well, that's 24. Set that equal to 9. Well, what's 35 minus 24? That's 11. 11 clearly does not equal 9. So the answer to 7/6 is no. That is not a solution to this equation, and therefore does not lie on that line. However, they also ask about negative 3, negative 6. So we'll take 5 times our x value of negative 3 minus 4 times our y value of negative 6. We'll set that equal to 9. Well, 5 times negative 3, that's negative 15. Minus 4 times minus 6, that'd actually be plus 24. We'll set that equal to 9. So negative 15 plus 24, that does equal 9. 9 does in fact equal 9, so the answer for negative 3, negative 6 is yes. That is a solution to 5x minus 4y equals 9. So far for this part, you're just simply taking your x and y coordinates, plugging in the x value for x, the y value for y, and if your left side equals the right side, that ordered pair is a solution. If the left side comes up not equal to the right side like this one, that ordered pair is not a solution. So that's how you'll know. Alright, time for a little bit different problems here. Now, okay, solve each equation if x and y are whole numbers. So we're going to solve each equation if x and y are whole numbers. We'll start with 2x plus y equals 6, okay? This time they don't give you ordered pairs, but they want you to solve the equation if x and y are both whole numbers. If we remember, whole numbers are 0 and greater. They're your counting numbers. They're integers of 0 and greater. There are no fractions, decimals, anything like that. Whole numbers are integers 0 and greater. No negatives, nothing. So, when you have a problem like that, first thing I would do is stick in a value for x. We're restricted to whole numbers here, okay? A whole number starts at 0, so we could put in, let's start with x equals 0, okay? So if we do that, we'll put in 2 times 0 plus y would equal 6. Well, 2 times 0 is 0. You just literally have y equals 6. So one ordered pair, your solution will be an ordered pair. You'll get 0, 6. When x equals 0, y equals 6. That's what that ordered pair denotes of 0, 6. What else? We could stick in x equals 1. So you'll take 2 times 1 plus y, set that equal to 6, right? Well, 2 times 1 is 2. You get 2 plus y equal to 6. Well, you got 2 plus y. You want to solve for y. So just remove 2 from both sides. You'll get y is equal to 4. So when x is 1, your y coordinate is 4. So the ordered pair 1, 4 is another solution to this equation. What else? Let's see. Let's say x equals 2. How about when x equals 2? So you'll take 2 times your x coordinate of 2 plus y, because we don't know what y is yet, set that equal to 6. 2 times 2, well, that's 4, plus y equals 6. Okay. Well, we have 4 plus y. We want to just find the y coordinate, so subtract 4 from both sides. You'll get y equals 2. So that means when x is 2, y is also 2, so therefore you get the ordered pair 2, 2. So far we have the ordered pairs 0, 6, 1, 4, and 2, 2. One more. I think we could do one more. What about if x equals 3? Well, okay, go ahead, take 2 times 3 plus y, set that equal to 6. 2 times 3, well, that's 6, plus y equals 6. Well, we want to solve for just y, so you got to subtract 6 from both sides. If you do that, you get y equals 0. So when x is 3, y equals 0. So you get the ordered pair 3, 0. If we were to try to put in 4 for x, you would get 8 plus y equals 6. You would end up getting y equals negative 2, which violates the fact that y is within the whole numbers. So we have found only 4 solutions to this. 0, 6, 1, 4, 2, 2, and 3, 0. Those are your 4 solutions to this equation, because we got to stick with the whole numbers. And I got more. I do have more indeed. So, alright, we have 5x plus y equals 7. So we got 5x plus y equals 7. Well, these have to be within the whole numbers again. So, start like any good place to start, let x equal 0. So put in you'll make it 5 times your x value of 0 plus y equal to 7. Well, 5 times 0 is 0. That leaves you with y equals 7. So when x is 0, y equals 7. Therefore, you get the ordered pair 0, 7. That is one solution to this. What about when x equals 1? Okay, well, let's put in, we'll have 5 times our x value of 1 plus y equal to 7. 5 times 1, that's 5. You get 5 plus y equals 7. Well, we have 5 plus y. We want to solve for just y. So subtract 5 from both sides. If you do that, you get y equals 2. So when x equals 1, y equals 2. So you get the ordered pair 1, 2. For good measure, let's try x equals 2. Okay, so do 5 times your x coordinate of 2 plus y equal to 7. Well, 5 times 2 is 10, right? Plus y equals 7. Well, we have 10 plus y. We want to solve for just y. So subtract 10 from both sides. You'll get y equals negative 3. Well, immediately one of the terms is violated when we do that. X is a whole number, but y is not. They both have to be whole numbers, because y is negative 3, and negative numbers are not whole numbers. So we can scratch that whole set of work. So your only two solutions for this in the set of whole numbers are 0, 7, and 1, 2. That's all you're going to get for your solutions in the set of whole numbers. Now, had it been the whole set of real numbers, there would be infinite solutions. And likely you would not be asked to even do this if it were the whole set of real numbers. So, thank goodness, who wants to be here till kingdom come and try and solve it infinitely? Even then, you would never solve it. Alright, how about 3x plus 2y equals 8? So we have 3x plus 2y equals 8. Well, let's go ahead here. Let's start like any good place, right? We'll do it when x equals 0. Okay, so you'll take 3 times your x value of 0, which is 0, plus 2 times y, set that equal to 8. Well, 3 times 0 is 0. You're just left with 2y equals 8. Well, you want to get y, so you got to divide both sides by 2. If you do that, you get y equals 4. So when x equals 0, y equals 4. And this is a viable solution because these are both in the set of whole numbers. So 0, 4 is an ordered pair that'll actually work to solve this equation. How about x equals 1? What if x equaled 1? So take 3 times your x value of 1 plus 2y, set that equal to 8, okay? Well, 3 times 1 is 3, so you have 3 plus 2y equals 8. You want to just get 2y by itself, so you subtract 3 from both sides. If you do that, you get 2y equals 5. Well, you want to just solve for y, so you divide both sides by 2. You get y equals 5 halves. Well, we have a problem. X is 1, that's a whole number, but y equals 5 halves. 5 divided by 2 comes out to 2.5 or 2.5. Therefore, it's not a whole number, so we can't regard this one. With x being 1, y equaling 5 halves, that's not a solution for the set of whole numbers. So far we only have 0, 4. What about if x equaled 2? So let's go ahead and set x equal to 2. You'll take 3 times your x value of 2, plus your 2y, set that equal to 8. Well, 3 times 2, that's 6. So now you have 6 plus 2y is equal to 8. Well, we want to just get 2y by itself, right? So we got to subtract 6 from both sides. If we do that, you get 2y equals 2. Well, we want to solve for just y, so we got to divide both sides by 2. If you do that, you get y equals 1. Well, this checks out because when x equals 2, y equals 1. And those are both within the set of whole numbers. So the ordered pair 2, 1 is also a solution to this. So, and it would appear if we tried to put in x equals 3, you would get 9 plus 2y equals 8. You would get 2y equal to negative 1, which y would equal negative 1/2. So it does not appear we can go any further. So your only two possible solutions are 0, 4, and 2, 1, if we stick within the set of whole numbers. Alright, I think we've seen those type. Let's try a few harder ones here. How about xy equals 4? So now we're multiplying x times y. And the parameters are we still stick within the set of whole numbers. So let's set x equal to 0. We'll just humor that for a second. So if x equals 0, you would take 0 times y, set that equal to 4. 0 times y, that's just 0. Well, 0 does not equal 4, so x being 0 cannot be a solution. Now, what about when x equals 1? Can we do that? Well, you'll take 1 times your y, set that equal to 4. Okay. Well, 1 times y is simply y. Y would equal 4. So you get the ordered pair 1, because when x is 1, y is 4, so you get the ordered pair 1, 4. And x and y are both whole numbers, so the ordered pair 1, 4 definitely checks out. What about when x is 2? So x is 2, you'll take 2 times your y, which would be 2y, set that equal to 4. Well, you just want to solve for y, so divide both sides by 2. You do that, you get y equals 2. So when x equals 2, y equals 2, that's a viable ordered pair because they're both whole numbers. So the ordered pair 2, 2, that's another one you can use. How about x equals 3? Okay, so you take 3, put 3 in for x, multiply it times y, you get 3y equals 4. You want to solve for just y, so you divide both sides by 3, you get y equals 4/3. Well, we know 4/3 is definitely not a whole number, so x can't be 3. That's not going to work. But what about if x equals 4? Well, you'll put the 4 in for x, multiply it by y, you'll get 4y equals 4. You want to solve for y, so you got to divide both sides by 4. If you do that, you get y equals 1. So when x equals 4, y equals 1, and that order pair works because both x and y are whole numbers. So you have 3 possibilities of ordered pairs for these solutions, for the solution to this. You have 1, 4, 2, 2, and 4, 1. Those are your 3 possible solutions within the set of whole numbers. Too similar, let's see. Alright, how about xy plus 7 equals 23? So we got xy plus 7 equals 23. Well, here's a trick. We want to get that xy by itself, right? We have a plus 7. We need to subtract 7 from both sides. So if we do that, I'm going to draw an arrow to symbolize this. We subtract 7 from both sides, you get xy by itself. 23 minus 7 is 16. Now we have a form we can work with, xy equals 16. Well, I think it's safe to say x can't equal 0 because you would have 0 equal to 16. That's just clearly not true. So, we'll take x equal to 1. How about that? So x equals 1. You'll put in the 1 for where x is. You'll have 1 times y. Y would just simply equal 16. So when x is 1, y is 16. They're both whole numbers. That works. You get the ordered pair 116 for a possible solution. How about when x equals 2? So you'll put in 2 for where x is, so you'd have 2 times y, which is simply 2y. That'd be equal to 16. Now you want to just solve for y, so you divide both sides by 2. You get y equals 8. So therefore, you get the ordered pair 2, 8. And that works because both x and y are whole numbers in this. So far, 116 and 2, 8 seem to work. If we did x equals 3, you would get 3y equals 16, which would mean that y would equal 16 thirds, clearly not a whole number. So y can't equal 3. I mean, x can't equal 3. But how about x equals 4? Let's try that. If x equals 4, you're going to put 4 in for x. You'll get 4 times y equals 16. Well, we want to solve for just y. Divide both sides by 4. You get y equals 4. So when x equals 4, y equals 4. You'll get the ordered pair 4, 4, and that works because 4 and 4 are both, in fact, whole numbers. So let's take x equals 5. You'd have 5y equals 16, giving you y equaling 16 fifths. Also not a whole number. That's not going to work. How about x equals 6? You would get 6y equals 16, which would mean y equals 16 sixths, which would reduce to 8 thirds, which is also not a whole number. How about x equals 7? You would get 7y equals 16, which would mean y equals 16 over 7. Also doesn't work, not a whole number. But how about if x equals 8? What about if x equals 8? So you put in that 8 for x, you would end up getting 8y. You set that equal to 16. Well, you want to solve for just y. So you divide both sides by 8, you get y equals 2. So that means when x is 8, y is 2. They're both whole numbers, so that works. So the ordered pair 8, 2 also works. Is there any other? Are there any others? Basically, when you're doing these, think of whole number factors of 16. That's all you have to do. And then just multiply them by each other. That's really all you're going to get. I didn't mean to make it more complicated than it was, but just think of factors of 16, for example, that are both positive numbers, and then just multiply them by each other. So if we do that, we know if x equals 16, that means we put in 16 for x, you'll get 16y equals 16. You want to solve for just y, divide both sides by 16, you get y equals 1. So when x is 16, y is 1. So you also get the ordered pair 16, 1. That's another one that will work, 16, 1. So we got 1, 2, 3, 4, 5 possible solutions to this. And I think we'll do one more for good measure, then we'll call it a lesson. Alright, what about... let's see. xy plus x equals 9. Alright, so we got to have whole numbers here. Xy plus x equals 9. Well, let's start with x equals 0. That's as good of a place as any, right? So if x equals 0, you'll put in your 0 value for x. You would get 0y, which is 0, plus 0 equal to 9. Well, 0 does not equal 9. So x equaling 0 is not a viable solution. But how about if x equals 1? Well, so for the first part, you would put in your 1 for x. You get 1 times y, which would just give you y, plus your x value of 1 equal to 9. Well, y plus 1 equals 9. We just want to solve for y. So subtract 1 from both sides. You get y equals 8. So when x equals 1, y equals 8. That's a viable solution because 1 and 8 are both whole numbers. So far we have 1, 8. How about if x equals 2? Well, if x equals 2, that means you put in 2 for your x. You'll get 2y plus 2. That'd be equal to 9, right? You want to solve for just 2y, so subtract 2 from both sides. You get 2y equals 7. Well, y would equal 7 halves. That's not going to work because y is not a whole number. So x can't possibly equal 2. What about if x equaled 3? So put in 3 for your x, you would get 3y plus that x value of 3 equal to 9. So 3y plus 3 equals 9. We want to just solve for 3y. So subtract 3 from both sides, you get 3y equals 6. Now you want to solve for just y. So divide both sides by 3, you'll get y equals 2. So when x is 3, y is 2. And that's a viable solution because 3 and 2 are both whole numbers. So far you have 1, 8 and 3, 2. Those are two possible solutions of this equation. Are there any others? I don't think there are. Nope, I think that's it, because if you try to plug in other numbers... Well, hold on a second. What if x equaled 9? What if x equaled 9? There is one more, I believe. 9 times y is what you get. So you get 9 times y plus 9 equal to 9. Well, you want to solve for just 9y. So you subtract 9 from both sides, you get 9y equals 0. Well, you want to solve for just y, so divide both sides by 9, you get y equals 0. So when x equals 9, y equals 0. And those are viable solutions because 9 and 0 are both whole numbers. So actually there are 3 solutions to this. You have 1, 8, 3, 2, and 9, 0. So basically when you work with these types of problems, it's pretty much trial and error. Just plug and play. See what comes up. So that's it for this lesson. The very next lesson, we're going to talk about points, lines, and their graphs. So I hope everybody has a good night. Take care.